Welcome to Links, our YouTube channel. My name is Ram Mishra and I'm your online instructor. So what's new in this video? In this video we will talk about Docker multi-stage build. But before start the lab session we need to understand few points, which is what is Docker multi-stage build and their use cases. So as you can see on my screen, this is the official documentation of Docker and clearly mentioned here, multi-stage build are useful to anyone who has struggled to optimize Docker file while keeping them easy to read and maintain, right? So let me try to explain this in a brief way. If we try to build our custom Docker image using Docker file and Docker build command, this process will start with an image which is only a base layer of the final image. This means that the image contains only the operating system and any other packages needed to execute the command. So if you only use a single Docker build process, then you are missing out some powerful features of build process. A multi-stage build process allow you to break the steps in building the Docker image into the multiple stages. This will enable you to create images and that include only the dependencies that are necessary for the desired functionality of the final application, cutting down on both time and space. And with the multi-stage build, you will first build the image that contains only the dependency needed to the build your application. And then after the image has built, you can add it in additional layers needed to create your application and configure it for the deployment. So in this way, you can build image with only the code necessary for building the application, and this is also used to optimize the container image and make them smaller. So let's start the lab session and we'll see how we can reduce the size of the Docker image using the multi-stage build environment. What is the syntax we will use? It is clearly mentioned here, so you can copy the image file from here also. Let me go to my VM. So guys, here you can see this is my VMware workstation and currently I have a one Linux virtual machine where I have already installed Docker tool. So let me show you the OS release version, the IP address of this base machine and Docker status. So host name CTL. So currently you can see I'm using RHEL 9.3 and the machine name is server.example.com. If I go with ifconfig ENS160 Ethernet LAN card, current IP is of this machine is 192.168.116.128. And if you check the docker hyphen version, so you can see Docker version is 24.0.7 is available in this machine. So let me check the Docker available Docker images and current container status by following command. Docker images, no images are there, and Docker ps-a, nothing containers are there, no container are there. So you can see currently I don't have any container on this machine. So let's start to understand the concept of multi-stage Docker build process. So let me create a simple Docker file to demonstrate how a Docker multi-stage build can be used to reduce the Docker image size. You would compare the final Docker image size for a single stage build and for a multi-stage build, right? So let's create a simple Docker file. So vim docker file, and let me write down the code. So I have already code in my notepad file. Let me copy it here and then I will explain the entries. You can copy the same code from the official documentation. So this is the normal, or you can say single stage Docker file. When you run the Docker build command, it will launch a build process starting with the base image, and the resulting image will contain the build tools and the source code, the runtime environment that includes the dependencies to run your application and libraries. But not all of those are necessary needed in the final image for the run to the application. So here in the build stage, you can see we start with the base image. In my case, it is Nginx latest image, right? That contains all necessary build tools and dependencies required to compile and package the application. My current working directory, the current working directory is set usr share nginx html, and then entire application code is copied into this stage, right? And then in the run instructions, I execute echo and apt get command to command and generate the, it will generate the artifacts, make a file, whatever the needed for the application. So I just simply update the packages and I make simple index.html file with this contain echo. This is demo web server from stage 1. So you can run any code like your Java code, MVM code, anything, you can build it from here. Let's build the image with the docker build command. So I'll save and quit. I run the command docker build -t first image and dot. So this command will build the Docker image and tag it with name first image. See, I press enter, building started. So you can see building is going on. So just wait, let it be complete first. Yeah, it's done. So uh, it's complete now. Let's check the size of the building image using the command docker images. Okay, you can see, you should now see the image, and you just whatever we just build it, and in the size column you should see the size of image. In this case the resulting image is 207 MB. Look at the size of 207 MB. The image name is first image and the tag is latest, right? That's a lot of space for a simple application with just a few line of code. I have just mentioned few code. So you can confirm that you can access the application by running docker container using the docker run command. Let's try to create a container. Docker run hyphen detach mode hyphen hyphen name. I'll give the name of web1 hyphen p8181 colon say 80, and the image name is first image. Okay, so this, let me press enter. Done. So basically this will create a docker container from the first image and mapping port 818 on the host computer to port 80 in the container. So if we move to the local host 8181 on your browser, we should see the application, view the application. So currently docker ps container is in up and running condition, port map is there, and let me try to go with curl command. Curl, what's my basic IP of this machine? 192.168.116.128 colon 8181. Yeah, hi, this is demo web server from first stage. So you can see I can access my web application from Docker host. Now let's move to the next step, restructure this Docker file again for multi-stage build. This is the only one stage build, right? So let's modify our Docker file with some content and we'll show how multi-stage Docker build works. So let me remove the older entry. I no required anymore here. So I'll remove that one. Let me try to open new, and let me go with this time multi-stage code. So let me copy, then I'll explain from here. Yeah, so now the Docker file, this Docker file, you can clearly mention two steps are there, or you can say stages are there. That is categorized by from statement. This will create two stage build process. First from here, and second, even I have clearly mentioned this is the build stage and this is the runtime stage, right? And the two forms are there, right? So however, stage 0 is a given a friendly alias as build, right? The first stage build the web application using Nginx latest image, right? And the second stage will serve the build application using Nginx 1.10.2 Alpine image, which is the minimal base image for Docker Hub, and given a friendly alias as run, here as build, here as run. It's aliases, right? Now in the second, you can see the working directory except usr share nginx html to maintain the consistency with the build stage, and using the copy hyphen hyphen from build command, right? This build instruction, we copy only the necessary file from the build stage located at where? Located at usr share nginx html. So here it is what? Here it is my index.html page, right? And this ensures that only the compile artifact are included in the final image. So now build the image again with the following build docker build command one more time, and let's see what happens. So I'll go back again the same command, and this time I just modify the tag only, say second image, right? Done, very quickly done. Now let's compare both image using docker image command. Docker images. Okay, you can see the first image and second image, and look at the size difference, 207 MB the first one, and look at the size, only 54 MB. So this way you can separate the build and the run environment in the same docker file. So look at the size, only 54 MB. So let's try to access the application by running the docker container using the docker run command one more time. So I'll go with the same command one more time, and I replace the new port. The port is 82 this time, 82. Image is not first image, it is second image, and let me change the container name also, is web2. Hopefully everything is okay. Press enter. Done. Let me go with docker ps command. You can see both are there. Web1 is running on 8181, and web2 recently which we have launched is 82 and 8 82 and 82, right? So let's try to hit on port 8282 one more time from the base machine. So if I try to hit not 8181, 8282, press enter, yeah, I can see my application. So you can see I can access my web application again from the Docker host, on this time on different port. So finally, we are in the conclusion that multi-stage build helps build the optimized Docker image that can run anywhere. The software deployments can be faster through this approach, and the image can be reused to save the time and efforts. And multi-stage builds are a great way to simplify your image creation process and save developer time. So guys, that's all about this demo. Hopefully you enjoyed and learned new things. Soon I will come up with another new interesting topic. Till then, keep practicing. If you feel something I have missed or you wanted to know more something else, please reach out through my social media links, which is the mention in the description. And if you like this video, please do not forget to like, share, and subscribe my channel and press the bell icon button for the latest update. Thanks for watching. Stay safe and goodbye.